Online, can you hear me? Online, hello, can you hear me? Hello, testing. Can you hear me? Hello? Can you hear me? No, not yet. No, okay. Sorry. Just want to. Yes. Okay. Cool. Amazing. You can hear me now. Perfect. So there's a delay between the web stream and also our live stream. So there's a couple of seconds delay. So just checking to make sure that everyone can hear me. Perfect. So yeah. So what I was talking about here in person was get started with your iteration 0 as early as possible. Although it's quite easy, can be finished quite quickly. Okay, so let's have a look at our course website on the lecture content. So for now, you can see that we talk about the basic course overview, structure, assessment. We talk about development, like using JavaScript, and also how we can have interactions between different files, like how we can export a function from one file and import a function in another file. So we talk about development. We also talk about coding together, so how we can collaborate using Git. So we talk about coding together. We also talk about projects. So what you have learned in 1511 is basically solving small separate problems through several functions or using files. But in 1531, we'll talk about more like larger scale software projects. So to have this software project, we need to have, for example, package management. So we use other people's libraries. We use npm install to use other people's code. We also, by using npm package or project, we have created that JSON file, like the package.json file. So we can have the metadata of the project and all the dependencies information in the JSON file. So for now, today we are going to talk about a new topic that we haven't touched yet, which is correctness. So what is correctness? What are we going to talk about in correctness? Testing? Yes. Verification? Yes. So we want to make sure that our software project or our code can do what we want it to do, right? So we want a 1 + 1 = 2. And our project won't give us like 1 + 1 = 3. Right? So we want to verify our code, verify our project, and test our project. And we will do a lot more correctness topic lectures in the future as well. So today's lecture is about dynamic verification. We will explain what is that, and then we'll talk about more in the future lectures. So testing is quite important in this course, and it's also quite important in any software project. So let's have a look. Yes, so basically writing tests, it is critical to ensure that our application works, our software works. And without very good testing suite or testing cases, can cause to very serious issues. So there are a lot of examples, like for example, Nissan have to recall over 1 million cars due to a software defect in the airbag sensor detect. So this is one example. Other examples, a lot. We have a lot of examples. For example, this one, the NASA's one, like losing like 125 million because of a software issue, like they didn't test the software good enough or whatever. So we'll talk about how we can test our project and our software. And testing is also a very important component in the software development lifecycle. So we have seen this picture in lecture 1, so week 1's lecture. So we very briefly introduced this software development lifecycle, and you can see that testing is here. So it's very close to development. So sometimes it's parallel, like testing and development is parallel, and sometimes it's sequential. Like testing can be even happen before development, can be after development, can be at the same time of development. And there are also many different types of testing. We'll cover some of them in this course, and you will learn some other testing in other software engineering courses. So for example, today we'll talk about unit testing. So unit testing is the smallest scale of testing in a software project. So basically we'll test whether your function works. So whether a specific function does what you want it to do. And other testing, for example, usability testing, it tests whether, like when you click on a button, does it lead you to the next page or the page before? So this is usability testing, or whether you can see my text or my content on the slide clearly. So these are usability testing. So it may involve having users or stakeholders to do the testing. And there are other testings, for example, performance testing. So what happens if 1 million users happen to use your software at the same time? Will your software broke up? So performance testing, and whether it can respond in a good speed, like whether you click on the button and will lead to the next page very quickly. So these are usability testing, performance testing, unit testing, and integration testing is can be on different scale. So putting together several modules together, integrate them together, and see whether it works as what you wanted. So integrated testing. And also acceptance testing is also related to usability testing. So get a user involved in the process. We'll talk about these testings in the future lecture, but today we'll focus on this one. To give you more context information, so software testing basically concerns with exercising, so run your code and observe its behavior to see whether it gives you the output or the return value that you wanted. We also call it verification. So we also call it like software verification. So on a higher level, like more general concept level, verification can be in two types, like static verification and dynamic verification. So the difference is for dynamic verification, we need to run your code. We need to execute your code and see the outputs or compare the output with your expected output. So these are dynamic verification. And static verification is without running your code. So before you execute your code, you can have some mechanism to check and validate whether your code has some potential issues or bugs. So I'll give you a quick example to show you the difference between them and what are they. So let's have a look at a script that we wrote together in our last lecture, which was the split before. So you may be quite familiar with this piece of code. So this in this code, like we define a function called manyString, and it should repeat this string for repeat number of time. Right, so for example, when we console log manyString 5 and hello, it should console log hello, 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 hello for 5 times. So this was what we want to have. And for dynamic verification, make it larger, larger, larger. Okay. So let me have a look where I am. I need to go to the folder of our last lecture. Okay, so when we run this piece of code, should be node split before.js and console log hello, hello, hello for 5 times. So we can see that it works perfectly fine, right? But there's another important part of verification is, for example, we accidentally used this manyString function like this. So we put them in the wrong order. Right, so this is not very easy to find. Like when you check your code, this is not very easy to find. And when we run this code, it returns nothing. So it basically gives you no hints like how to find the issue is or the bug is. So this is something that we'll talk about how to solve it in the static verification. So before we even run this code, we'll get information of potentially where's something wrong. But today we'll focus on the dynamic verification. But just to give you, but this example was to show you the difference between static verification and dynamic verification and what they are. So we had a student come to me today before the lecture and asking whether we'll talk about security. So we'll talk about safety, but not security. So they are very similar terms, but they are different. So safety means like we want to protect our software. Like we want our software to be safe, meaning that we want to protect from accidental misuse. So for example, the other example, we put a string and number in the wrong order. So this is potentially an accidental misuse of our software. So this may be from the user's input, they put something in the wrong order, or they have an unexpected user input. So we want our software to be safe, protect from accidental misuse. However, security is somehow out of scope for this course. So if you are interested in security, you may want to take other courses. And security will protect you. Security is about protecting your software from deliberate misuse. Like someone just want to delete your web page, hit your software, or like make your software not work as expected. So this is what security concerns about. But we'll talk about safety. An example of safety is memory safety. So when you learn in 1511, when you learn about C, you know that we need to be very careful about memory, right? So C is not considered as a memory safe language. So for example, you try to use the memory that is not allocated yet, so it causes an issue, right? Or your array is allocated like only 5, but you try to reach the 6 index in your array, so that would cause issue. So C is not memory safe, but comparing with C, JavaScript prevents your access to memory that is not being initialized or allocated. So it's quite dynamic with the memory allocation. So for example, in an array, we can always push more elements or more values in an array. You can also delete some element from your array. So it's more safe in the term of, so JavaScript is safer in the term of memory safety. Yeah. So even for dynamic verification, there are also different categories. So verifying our software during the runtime, there are also two categories, including testing in small or testing in large. So the smallest unit of dynamic verification is test the function. So unit testing, so test a specific function and see whether it works as intended. And testing in large can be like testing a module or 2 modules, integrated modules, and these are all can be tested during runtime. Like so, when you run the function, when you execute a function, you can test whether the output is you want. We'll come back to that. Yeah, mention. Okay, so before we move on, there's a quite interesting or important saying is testing shows the presence rather than the absence of bugs. So what do you understand? How do you understand of this sentence? So does that mean that if you have a very good or pretty good test, it mean and your code passed the test means that there's no bug in your code? Is that what it means? No, maybe because your testing is not complete, or maybe there are some edge cases, right? But if you have a very good testing suite, and it may shows you some bugs that you need to fix. Right. Okay, let's have a look at some examples before we come back to more like conceptual, theoretical information. So let's have a look at some more examples and demos. Get even. Yeah. So here we defined an example function called get even. So what we want is, given an array called numbers in the input in the parameter, what we want is iterate through the values in this array, and then we want to return an array with only even values. So for example, if the number, if we have a test number which is 1, 2, 3, 4, and what we want, oh sorry, I forgot to have this one, declare it first before you use it, and what we want is have console log and then get even test num. What should be console logged? Hey, wake up. Should it be? So let, 2 and 4. Any other answer? Okay. Oh, sorry. So let's have a look. CD do. Oh. So let's node and then even testing 1.js will be 2 and 4, right? So you can see that it this example iterates through the values in this test number and push the even number to this evens array, and then we console log this returned evens array. Yeah, question.
With the output, where did the space come from between the square bracket?
Where's the space come from?
The terminal.
In the terminal?
The output has like a square bracket space.
Oh, this is just how it shows in the terminal. Yeah.
Because in C, we don't really have that.
Okay, so it's just how it looks. Yes. Cool. So how are you going to test this get even function? Like before we talk about any like JavaScript methodologies of testing. Would you just have console log it, right, and see whether it's 2 and 4? If it gives you 1, 2, 3, 4 or 1 and 3, you can know that there's something wrong. Right. And this is what you have done in 1.5.1.1 when you do debugging. Like printf something and see if the output or return printf value is the right one. However, this is not very scalable, right? What if there are a lot of cases that you want to test, and then you need to console log all of them. So for example, this is the test number 1, and you may have some edge cases like test number 2, 3, 4, 5, 6, and you need to check all the console logged values and compare with like what do you have done here in the script, like what do you have console logged, and then compare whether you get expected output. Right, so this is not very easily scalable. It can be helpful for debugging, but not for testing large-scale software. Right. So to solve this problem, we introduce we need some more modern JavaScript testing method. And one concept that is important is called black box testing, meaning that when we test this get even function, maybe or perhaps you do not need to understand what's in the function, right? You only need to know what is expected output for get even. Right, so you may have a a spec, like somebody tell you, for example, a client asks you, please implement this software for me, and I want this software, I want to have a function that can do this and that. So they give you the expected output. Right. So when you plan for the testing, you do not need to worry about what's inside. You only need to know when you run this function, when you call this function, it should give you the expected output. So this is called black box testing. So even before you actually write the code, you can actually already have the test cases. Right. So before you write the get even function's body, you can start to write the testing. Like for example, given an array 1, 2, 3, 4, when I use get even, it should return me 2 and 4. So this is called black box testing. And this type of testing relies on testing abstractions. So sorry, concepts again. So abstraction is the notion of focusing on more higher level understanding of the problem rather than worrying about the details of how you implement that. And we actually do this all the time in our real life. For example, when you drive a car, you do not know how the car is built, like how is the engine built, like how is the computer inside your car is built. But you know when you turn, and then you can turn left and right, and you can speed up, speed down, and you can stop, right? So these are all black box. So we call them black box and abstraction. So when we test our code, we always wanted to view our function we are testing as abstraction or black box. So let's have a look at another example. Remove walls and factorial. Yeah. So you have been writing stubs for iteration 0, and it looks very similar to this, right? So this is a common practice in software engineering. So you have the function, and then you write the test, and then you write the body of your function. Okay, so we treat them as black box. So given a function, and then we can start to actually write the test. So even before we write the body of the function, we can know that when we console log remove walls A, B, C, D, E, it should console log B, C, D. Right? And similarly, when we console log factorial of 3, it should return us with 6. And same for factorial 5, it should be 120. So this can be helpful, like writing the test before writing the function's body. Because when you are, so if you are the person that writing both the function and the testing, so if you write the body of the function already, you may have some thoughts like what this function should be look like. So it will affect you when you write the case. So you may be biased, like when you are writing the test cases. So you may only test the cases that you think might be need to be considered. So you may be biased, like when you are writing the test cases. However, if you write the test cases first, and then you write the body of the function, if there's something wrong, it can be picked up. Yeah. Yeah, okay, so we mentioned that when we console log something, it can test, but it's more useful for debugging. It's not scalable. So we need a tool to help us scale this testing process. So the tool that we are going to use is called Jest. So Jest is a JavaScript framework. It's a framework, but it's very similar to the packages that we installed in our last lecture. So remember last lecture, we used npm install the date function. So we can use other people's scripts for our own software projects. And Jest is very similar to that, can also be npm installed. So it is also some scripts written by other people, but it's also different in the sense that it's not a library that we call and build on top of. Jest is a framework. How to explain that? So for example, you are building a house, right? So you can build everything yourself, like brick by brick. But what you can also do is you invite an expert builder who help you build the skeleton or the structure or the most important part of your house. But you can also personalize your house with your own details. Right? It's more safe, like because the framework is well tested by a lot of other developers. It's well established, it's very stable. It's like the expert builder who help you build the skeleton of your house, but you can also customize yourself. So this is Jest. It's a testing framework. And there are, like other than Jest, there are also other testing framework for JavaScript. But Jest is the most popular one that is used in industry. So we teach you everything that is like commonly used in industry. We can have a look here. So you can see that other than Jest, there are a lot of other framework that you can use for JavaScript testing, but Jest here is the most commonly used, is the most popular one. And you can like npm install Jest framework so that you can use the testing framework to test your project. So what we can do is we can use npm install Jest. I will come back to this save dev. So let's just install it first. Shall we go back to our untitled project? So we can continue building our untitled project. So this is our untitled project, so where we stopped from our last lecture. Okay, so you can see that this is what left from our last lecture. So this is the package.json file. So you can see that dependencies that we have already installed, including the date function and the random library. So now we can install another dependency called Jest. We run npm install --save dev Jest. So why do we have like the --save and dev? Before we only used like npm install date function or npm install random. The reason is that these functions are needed when the user uses our software. So these dependencies needs to be will be used by the users during like after the deployment. Right. So for example, when a user wants to check whether date is valid, they need to have access to the modules for the date function, and same for random. However, the Jest is for testing. So testing is only to be used for the developers rather than the users. Right. So this dependency is only useful during development or testing. It's not useful for the users. So this is why we had the --save -dev. And you can also see on this package.json file, the Jest is added here and the dev dependencies rather than here together with the data functions under the dependencies. So this package.json file helps you keep track of all the modules that you installed. Like what are to be used only for development, what are to be used during deployment. Right. So this is why we had the --save. Yeah, so now we have installed Jest. However, to have our project work, there are some environment settings that we have to make, unfortunately. But for your labs and major project, we set up the environment for you. So you do not need to worry about set up the environment. So everything is set up for you. But to make you have an understanding or background information of how we set up the environment. Like it's not totally a black box for you. So I will quickly show how we do it. But you won't be required to set up the environment for your project. We'll set up for you. So what we'll need to do is we'll add a file called this is it. Called this Babel file. Now we should be able to use jest for our testing. Okay, so now the question is how. So how can we actually use this jest for our testing? So let's explain it through some demos. Okay. So again, we need to have this remove walls function, but nothing in it. It is still empty. Remove walls or remove wall. Yep, it is here. And so this is the file containing our function, like remove walls function. We'll have another file where we write our tests. So we will have a file that is specified for our test script, for our jest test script. So to be able to do that, where is it? Sorry, I have too many files open. So here's the remove walls function that we want to test. So to be able to test this remove walls, to call this remove walls in another file, remember that we need to export. We need to export this function so that we can import this remove walls in this test file. Remember how we can call functions from another file? Like we need to export it first, then we can import it in another file. So now, okay, so this is the syntax for writing jest test. So it's not very complicated, but may seem very new to you, but you will get more familiar with it. So this is the syntax for writing jest test. So there are several layers that you can see. The top layer is describe. So, and then under that is the test, and then at the body of this test. So the describe is more higher level, describing what we are going to test. So for example, we are describing here, like we are testing remove walls function here. And then for this specific test, we also give it a description, like we are testing the inputs or the strings with no walls. So this is the test for the cases that there's no walls. And then expect to equal is the function in jest that you can use. For example, expect this remove walls of CBD to equal BCD because there's no walls in it. But we can also write more. We can have more test cases. For example, we can have example one, and this is TTYY, TYTY, and the expected output should be TY and TY. Alright, so this is the syntax of jest testing, but you can simplify it, make it easier to rate by just doing something like this. So we do not to declare the extra example and example one. So you can write test cases in here. So you may wonder, what is this expect to equal? So these are some functions or methods that defined in jest, and there are more that you can find. So we have the link in the slide, link to the jest documentation. So to equal, expect to equal is actually a matcher of jest. So you match the output of your function to the expected output or returned value. So the syntax is expect something to be, to equal, so there are multiple different matches. So we used to equal, but to be is another one. They are all matches. So we will use both to be and to equal. And there's also to be greater than, to be less than. So expect the value to be less than, expect the value to be greater than. So these are the matches in jest. It's predefined for you. You can just use these functions or method after you install the jest framework. And there are also something for strings. For example, expect something not to match, or expect a string to match. You do not need to remember or memorize all these matches. So whenever you need to use a match, you can just open this page and find the one that can help you. A question? Can we use? The question is, can we use console log to test? Asserts. Console asserts? So you want to test it in the terminal? Yeah, so you can, but it's similar to like console log. It's not scalable. You are still printing something on the terminal. So using visual tools or printing information is not scalable. So you need to check one by one. But for if you're using the jest, it's much more scalable. We will have a look. So let's run it. Okay, so let's actually call this function so that you can get a. Where's my terminal? Yeah, here is it. So how can we actually call this test function? So the way we call it is by using another. Looks a little bit. Oops. Oh, what is it? What happened? Sorry. So this is something that we need to use. Uh-oh, I did something wrong. So this is the wrong terminal. Okay. Just. Okay, so this is what you can see when you actually call this function. And the way that we run this test script is a little bit weird. It's something like .node modules -bin -jest. So what is it? So it's actually something that you installed when you run npm install jest. It's in the node module under the folder of .bin, and there's something called jest. So this is the script that you can use to call a function. So after you run npm install jest, everything is available for you to use. And this is the test file that we just wrote together. And this is what is returned. It says that the test passed, like no error or issue or matter returned. And you can see that we, when we defined the test view, we call it remove walls, and it is here. And this is the the more detailed testing case, deals with no walls. And the test suits, there's only one test suit here, and it passed. You may wonder, like, why it's passed? Like, we haven't write any code in the remove wall function, right? It's because we return the string that is inputted. So it's the same. Like, what is returned is the same with what is, yeah. So what is the bracket and two arrow mean? So we'll talk about it in the lecture in week 4. It's advanced functions in JavaScript. But for now, you can just think of it like a syntax in jest test. Yeah, because this course is a very heavily project-based course. Like the purpose is that you can have a project at the end of the term, like you can have. But in reality, like when we develop software project, there are a lot of interdependent concepts. So for example, we have seen like the package.json file, but we will actually talk about JSON file in the next lecture. But we have to introduce you what is package.json file so that you can use NPM. And after you have learned NPM, you can actually learn how to write JS tests because it depends on each other. Yeah, but we'll come back to that in a future lecture. But for now, you can just think of it like syntax. So describe is the more higher level of your test, like what you are testing. So now we are testing this remove walls function, and then more detailed test cases. And now we can actually add more test cases. What do you think needs to be tested for the remove wall function, other than the case like with no walls? What are the other cases? What about all walls? Deal with all walls? And AEIOU, and should return nothing. Is that right? Yes? Any question? Yeah, question. Sorry.
It depends on what remove vowels returns in the case of nothing left. It returns an empty string or maybe null.
Sorry,
Doesn't it depend on what remove vowels returns when nothing's left? It returns an empty string or it returns null?
Can someone sit closer?
You're saying it depends. Like, you're saying depends what our code does. Are we returning null or empty string?
Okay, so that's a good question. So the question, repeat for the online. So should that be empty string or should that be null? Right? So it depends on how you write the function. But here we had a step, like we already had what are the parameters. It should be a string, and what should be returned is also should be a string. So the expected value should be an empty string if we want to remove walls. But if you write your function and it returns a null, there should be an error message. Yeah. Or maybe we can have something like deals with random walls, random single wall. So what about in a string we had APTY, another had QWU. It should return a PTY and then QW. Is this right? What are the other edge cases that we may need to test? Yeah.
Removing empty strings, invalidating for special characters even.
Special characters in there or empty strings.
Yeah, or like you could
Use a number instead. Deals with unexpected inputs. What about that name? So what about we had a 2 here, or what if we had an empty string here? So for empty string, it should be empty string. Or a good question, what should be here? What 2 should be here? Like what should be, like remove walls for 2 to equal? Yeah, I agree. It should be 2 because they will treat your 2 as a string rather than a number, right? And it's not a wall, so it should be kept. There may be other test cases. For example, what about deals with multiple walls, right? So what about we have AAYY? It should return YY. Right? Similarly, maybe we have YUUY. It should be YY. Same, right? So there are a lot of different test cases. So these are done actually before we write the code. Assume that we have write a complete test suite, and now we start to write our code. Okay, let's have a break and think about how you are going to write this remove walls function. And let's come back at 3 p.m. Welcome back. Welcome back. Can Alan hear me? Okay, so we got question about how and why using Jest can scale up the testing, like comparing with console log. So I will show you before we actually write the remove wall function. So we have write some test cases here together. Like this is the wrong one. Yeah, so this is the test cases that we wrote together, right? But there's nothing yet in the remove wall function. So what if we run the Jest test now? What will happen? You can see that this is what returned. So here I run Jest and then the jestlib test file. So I run this test file. It will tell you it fails because we haven't write the removal function, right? And we test the different cases, and it shows that the test failed. And it shows that the describe like more high level, like we are testing remove walls. And these are the test cases that we wrote together. So you can see them here. So these are the test cases we had, like deal with no walls, deal with all walls, deal with blah, 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 blah. So some cases the test passed, and for most of the cases it failed. And what Jest will show you is where and how and why the test failed. So for example, deals with all walls, the expected output should be empty string. However, it returns us with AIE. So you can see the comparison that Jest gave you, right? And for the next one, deal with random single walls, you also had this extra A here, extra AA here, and a summary here. So this is how Jest is powerful and scalable for your testing. Like it's scalable in the sense that you can test a lot of test cases at once. Like you only run once, like call this test file once, and then it will run all the test cases and show you the summary of what works and what didn't work. So this is why Jest is powerful in scaling the testing process. Otherwise, you will need to console log for this one, console log for this one, console log for this one, console log for this one. Right? So when you have a lot of functions that you want to test and a lot of test cases that you want to have for each function, using Jest will save you a lot of time. Right? Yeah. Okay, so now let's come back writing this remove walls function. Any idea how should we write this how should we write this remove walls function? Yeah. Okay, what about we invite one of our students to come here and write the function? It doesn't need to be complete, and we can have multiple iterations on it. Any volunteer? You want to have a try? Yeah, come. Thank you. Yeah.
Would the string be like an array?
Hmm?
Would the string be like an array?
Just a string. It's a string. String is a string. So like A, B, C, D, E, F, G.
Yeah. Like I'm thinking of the for loop.
Yeah, sure.
Like for, I don't know if this works, char of
Let's
string.
have a try.
Oh, sorry, not B. Oh, wait. Because you need a new string, right?
Yeah, we need to return this new string.
Yeah.
Could you do like if it's checking like an individual character within that string, find out it's just like console log nothing, so it doesn't print that.
Do you want to come and help?
Sure, yeah.
If you just like continue here,
Yeah.
logic outside,
Yeah, and then
like inside the if statement, put continue.
yeah.
Yeah.
Otherwise, you can put you can make like a new string, like
Without it,
yeah.
or
so,
could you?
let
For char ob string, so is it checking every character within that string, right? So if it's checking one of them and it's a vowel, couldn't you just do like console log and then just quotation marks with nothing so it doesn't print anything? You know what I mean?
You can try.
We can try. We'll try.
yeah. I was thinking something like this. So if you find a vowel, then you skip over it.
Yeah.
Otherwise, you add the char into the new string.
Let's try it.
New string outside the for.
Oh yeah. Right outside the for loop.
So yeah, like you're running a for condition.
Yeah.
Each iteration you're making a new empty string
Oh yeah. That's right.
that you should do.
Oh my god, I don't know how to use a Mac.
You need to declare char somewhere. Char is not declared.
I'll go like for let char or const char. I don't know which one.
Yeah, let char string.
Continue string.
Yeah.
What's this line though? New string plus equals char.
Yeah. So this should be here. So basically, you just skip over the vowel.
Yeah.
But otherwise, if it's not a vowel, then you add it, right? But then you also have to consider the capital vowels.
Let's try that. Let's try that first. See if that works.
Like, wait, hang on.
Just copy it. Yeah.
What the heck? Do you know how to use a Mac?
Yeah, I'll use a Mac. Just copy the whole thing. Oh. Just with capital ones.
Yeah, capitals.
Yeah,
and then
okay.
Capital AEI. Yeah, but
Like that.
yeah.
Yeah?
Yeah.
Yeah. I don't
Basically,
know.
yeah,
I don't know
like
if that
that.
will work.
Yeah, and then we can try this.
We should see.
And then return the string. If char equals that.
Well, it'll check. Or should that be an else if?
No, it doesn't matter because we'll check this and then we'll check
And then we'll
this,
check that.
right?
And then okay.
Perfect. Thank you so much. Thanks. Yay.
I didn't do anything, but you're welcome.
Yay.
Do I go
Ready?
back?
All good?
Do I go back?
Yeah, please, thanks. So what we do next is we run our test and use our script to check this wonderful gentleman's script. Okay, so I'm not checking it, I'm using the script, just the script to check that. Okay, exciting? Perfect, everything passed. Yay, great. So, and you also considered an aspect that we didn't consider during our writing of the test, like the capital letters. We didn't consider that in the test, so that's a very good one. So we should add that case to our test. Deal with capital vowels, and you can write them. Have a couple tests A, E, and should be nothing, right? Amazing. So you can see that testing can be helpful if you write it before you write the function's body, right? So give you the confidence, although maybe sometimes your test unit is not complete at what we had. So if there's something, if you passed all the tests, may not always mean that you write the perfect code, but your testing can be very helpful. Like for example, in the example that we showed before, right? It tests your code. Perfect, thank you. there's something else, like some other things we can do actually to achieve the same things, but maybe with less lines, less code. The way that I normally do is use Google. So what I do is JavaScript, and then remove a substring from a string and see if there's any predefined JavaScript method that we can use directly. So this is the top one that comes to our scene. Then you can see, well, there's something potentially we can use. For example, replace. So replace is a function for string. Like a good question that asked by one of our students, like we can replace a word with an empty string. Alright, so this is something we can do. And there's also another function called slice. Where is it? Yeah, it's not in this one. Oh. So slice, and also there's another one called replace all. So JavaScript is very powerful. That there may be a lot of functions method that you never heard of or haven't used yet. So what about before you write something, search on Google and see if there's any predefined function or method that you can use instead of writing everything yourself. So it might save you time and have less lines and easy to debug in the future. But perfect, that's very good script. Thanks so much. Great. Let's come back to our content. So one thing that you may find now is not very convenient is when we call the test. So what we are doing now is like we find the jest in the notes module folder under the .bin folder. So this is not very convenient. So you can see that I also copy and paste this line here instead of typing everything. So is there any way we can simplify this process? Remember, like last lecture, when we talk about a package.json file, we mentioned that we can write our own script. Like the example we used was Bill and Yuchao. Like I can have something like, this is what we have from last lecture. We had Yuchao, and then I can console log something like hello Yuchao. Remember that? So what we can also add here is add a script called test and .jest. And how this works is now instead of doing something like node module -bin -jest, we can simply have npm run test, and it will do the same thing. Npm run test. And it will do the same thing. It's much easier, right? And you can also make some modification. For example, when you call npm run test, what if I only want to test this just lib.test.js file? What if this is the only file that I want to test? So I can modify that and remove this, and it will do the same thing. So you can customize the script in the package.json file. So it's much more convenient. Or what if you want to just test everything in this folder, right? So you may have a few test files under this folder. What if you want to, with one script, one call on the terminal, and you can run all the test file under this folder. So you simply, what you can do is just call npm run test, and it will find all the test file in this folder and run those files together for you. And how just find or identify those test files is by looking at the naming of your test file. So you can see that the example that we showed was just-lib.test.js. So this is a typical way of naming a test file. All right. And what you can also do is you can do just-lib and then spec.js. It's the same. So there are two ways of naming a test file, just the test file. Is either name.spec.js or name.test.js. and Jest will find all these test files itself. Another question that you may have is, do we need to keep the test file's name the same with the file that we want to test? So for example, we had here like jest dash lib.js for the file, like for the remove walls file, and our test file name was the same, right? Is this required? The answer is no. This is not required. You can change it to some other names. For example, we can have black box, and it will do the same. It still works. However, it's a good practice to keep the name the same. So it's a good practice to make sure that your test file's name is the same with the file that you want to test. The reason is that it's easier to manage in the future. Right, so you know which test file is related to which file that is to be tested. So it's a good practice. So we recommend you to keep the name the same. So let's change it back to jest-lib spec. But it can also be, as we mentioned, can also be test. They are the same. And when you add in the package.json file, this line, it will find all the test file under the folder. Okay, so you can see it's very easy to use, and it is scalable when you have a lot of tests, a lot of functions that you want to test, or even a lot of files under the folder that you want to test. It will run at the same time, like it will run the test for you together. And it will have this kind of beautiful summary. We can also play a little bit with this test file. What we can also do is we can have an upper layer of this describe. So what we can have is, for example, what I'm going to do is copy this describe here, and so I'm adding one layer for our test suitcase. So for example, maybe we have the upper layer, which is remove walls, and for here we may like normal cases, and then I'll split them into normal cases and edge cases. But you should have a more make sense naming for the edge cases. And what I'm going to do, delete some of them from here, and delete some of them. So separate the test cases. So you can see that you can have more meaningful test cases, like under different layers, groupings. So now when you run the test, it will be like this. So you can see from this summary, so all of these tests is about remove walls. One group of them is for normal cases, another group of them is for edge cases, and under each of them there are some test cases, like specific test cases under them. Right. Yeah. Oh, good. So you can see it's quite powerful, easy to manage. Yeah. So this is what we just showed. Yeah. So we showed just now, like we wrote the test cases first and then read the body of the function. So this is a common practice in industry as well. So the test cases may come from a requirement from the stakeholders, from your project owners, or the spec. So given the spec from the stakeholder or the project owner, we can write the test cases. And after we write the test cases, we can come back and write the body of the functions. So we are typically be working with the information that tell us the constraints placed on a list of the inputs as well. So for example, a very good question, like will the return value be a null? No, because this is defined as a constraint. It needs to return a string. Right. And the documentation of the constraints may come from a variety of forms. For example, the spec. The spec for your major project is one form of this kind of documentation of what are the expected behavior of your project, right? So the constraints and everything. So this is what we call by behavior. So what is behavior of your software project or your code? Is how your program responds when being used. This is what we call behavior. So for example, when we call, let's have a look at the example. So when we call this remove wall function and we give a string as ABCD, it should return the wall. So this is the behavior. So this is what we call behavior. However, so you may notice it in the later weeks of the term. So there are some defined behavior in the spec, but there are also some undefined behavior. For example, for a login function, like for any kind of platform, we may have a login function, right? So some defined behavior may be if the user given a password that match its username should allow this user to log into the system and get access to the features. So this kind of defined behavior. But there may be some undefined behavior. What if the user just do not follow the instruction, put random things and refresh the page like quickly and put random things, click on random buttons everywhere here there. So these are undefined behaviors and can also, so we cannot define every possible edge cases in any spec or on any requirement document from a client, from a stakeholder, from your project owner. So they cannot define any edge cases. So this is very common. And it's also not feasible to define like every possible edge cases. It's not efficient, right, in reality. So there may be endless number of like edge cases, right? But there are some edge cases that we need to consider, but some maybe like above the scope. So what to do with undefined behavior? So undefined behavior is where behavior is not defined at all, like from the constraints in the spec, from the requirement documentation, or the behavior that is not common sense. Like common people won't do that. So because the case is beyond the reasonable scope of the expectation, so it's not common. And shouldn't occur within a reasonable use of the system. An example maybe try to find the square root of -1. Right. But as long as you follow all the constraints, you achieve what is required in the requirement documentation, all the spec from the stakeholders, the implementation details is always in your hand. Like how you implement or write the code for remove walls was perfect. Like you two wrote the perfect one. But there are also other ones, like I can use the string methodologies that defined by JavaScript. It also worked. So as long as you achieve everything that's required in the requirement documentation, it should be fine. Like the implementation detail is up to you. Like you can make your good choices. So this is same not only in our project, but also in any software projects. So the implementation details, like everybody may have a different code, but it should achieve the same goals. Okay, amazing. Any question about this part of the lecture? Yeah, question.
How do you use .babel RC? I can't get it online.
Yeah, so this is how we set up environment. So this is your question? Yeah, so to be able to use Jest after we use npm install, so we need to add this file to the project so that the Jest can work. So if we remove this, it will give you an error message. But this is about setting up the environment. It's not about just testing. Yeah, and we will set up the environment for you for a major project and lab. You do not need to worry about that. What I just showed here is just to make sure that how we set up environment is not a black box for you, so you know how we did it. But you are not required to do that. Yeah, question?
Isn't just stored in a bit folder? So why do we need this file?
Why do we need this file? Okay, that's a very good question. I was looking for it before the lecture, actually. I did my homework. Okay, so why do we need it? Okay, that's a good question for me. Any guess? What do you think? Yeah.
It's needed to transform your JavaScript code so that it can be read by Jest.
Transfer your JavaScript file.
Transform the code
Transform the code.
so it can be read by Jest.
Can be read by Jest. Okay, I think that is right. Similar to my note. Yeah. I'm not too sure, to be honest, so I just follow the instructions setting up the environment, but that sounds like a very meaningful, makes sense explanation. Yeah. Any other question? All good? Yeah. Cool. You will going to write a lot of tests in this course. And it will start from next week, your lab. So week 3 lab, you start to write a lot of tests. Writing tests will also start from iteration 0. So not only the course will provide tests for you to test your code, you will be writing your own code in the future. Cool. Okay, if no more question, we have a very short lecture here about data interchange. So you may be a little bit confused about what is JSON file. So what is JSON file? So and there are also some other files that similar to JSON files. So they are not language that you can execute. Like you cannot run the script in JSON file. Right. So what you can see, for example, in the package.json file, it's more like you are saving some information or data about the project, but it's not executable. Right, so JSON file is not executable. It's a file that can store data, follow a specific structure. And the structure looks very similar to JavaScript object. Right. So this is a very, but there are also other languages or files that are similar to JSON file like YAML or XML file. But what are they? So what they are? So they are actually a kind of standard interface for our software project. So for example, in a web app, somebody may prefer to use JavaScript for front end and using Python for back end. So how could the data communicate between the different programming language? So what if you write in some data for the front end using JavaScript, and you need to process this data in the back end using Python? We need to have something in the middle, right, to transfer the data type. So this is called the standard interface. So what is the standard interface in our real life? So for example, a USB cable can transfer data between my laptop or computer, or like my phone with my computer, right? This one or this one, or railway. You need to have a standard, right? So that different trains can all go through, use the same rails. So they are standard interfaces. So similar to the example that we explained, like how we can transfer data from front end using JavaScript and back end using Python, right? So this is standard interface for data. And we need a data interchange format that can be read using JavaScript, can be read using C, can be used reading Java or Python or whatever. So these are called data interchange format. And there are 3 main interchange formats, which are JSON, YAML, and XML. So these are data formats. And JSON format is a format made up of braces for objects, square brackets for arrays, or So you can see that it's very, very similar to JavaScript object. But there are also differences. For For example, let's have a look at this one. So can I have a comma here in our JSON file? No, it will have an error message. But in a JavaScript object, this is allowed. So this is one difference. Other difference is object keys must be strings and must include atmosphere, so the codes. So in a JavaScript object, we have seen that, we're saying example, let me find an example. Where's the example? Split before. Where's our JavaScript objects? Let's find an example. Yes, so here's an example. So you can see that we can have we had no codes in for the keys in a JavaScript object. However, in a JSON file, we have to have the quotations for the keys. All right, so these are the two differences, like the syntax of JavaScript object and a JSON file. They are like JSON data object. Yeah, so this is the difference. Otherwise, it's the same. Looks very similar, right? So you can think of it like JSON file. It's a file to save data. You cannot run it. You cannot execute it. It's just somewhere that you can save your data in that. But the powerful thing of JSON is that it's a data interchange data format, meaning that majority of programming language can somehow save the data in a JSON file and can also read data from a JSON file. So for example, for your front end, you use JavaScript, you read a user input or some information, and then you can save the data in a JSON file. And then for a backend, for example, C or Python or similar or same JavaScript, you can also read from this JSON file and make it a JavaScript object and work with the data. So this is why we need it, why it is important. So here's an example of exactly how we can read and write with JSON file. So this is an example. So to be able to use, to be able to read or write to JSON file, we need a library, like JavaScript library called FS. And this is a predefined library, like we do not need to use npm install to install. So after you have installed Node.js, you can start to use this library called FS. And this library is useful when you want to read or write to our files, especially JSON files. So we import this library and we define a data structure. So for example, your user data, right, a user information, login data. And then you can use JSON.stringify this data structure. So before we write to a JSON file, we need to JSON.stringify. So make it a JSON string before we write it to the JSON file. Alright, so we need to somehow transfer your JavaScript object into a JSON string before we write this JSON string to the JSON file. Alright, so this is a process. So this is just a process like we have to follow, unfortunately. And then we can use FS method called fs.writeFileSync, the file that we want to save this data to, and the data, the stringify the data. And with the flag W means that we are writing to this file. So let's have a try, have a look. We are a bit short of time. Should be fine. So this is the JSON stringit file. And what we can do is let's go to this folder first. And then we run node JSON 8.js. So you can see that a new file was created just now. This export.json file. And this is the JSON string. So this is how we can write to a JSON file. So if you want to have a database, like somehow save your data without very complex database structure, you can just save your data like this in a JSON file. Yeah, question. Can we use another language to read from JSON file? Yes, you can. Majority of programming language can read from JSON file, not only JavaScript. For the assignment, we are using JavaScript. Yes, for the assignment. Yeah, unfortunately, you cannot read in Python. Yeah, but after you have learned JSON file, you can use it in your other projects, like outside of the 153 major project. Yeah, so this is how we can write to the JSON file. But we can also read from JSON file. So what if we want to read from what we have write to the export.json file and make it a JavaScript object so that we can use the data for other functions. Similarly, we still need to import this fx library to be able to read. And the method that we use is called read file sync. So we read from this export.json file and we flag it as R, like means read. Before we actually use this JSON file as a JavaScript object, we need to use json.parse to parse it into a JavaScript object. Otherwise, this JSON, after you read, is still a JSON string. So it looks like this. So it's not an JavaScript object yet. So to make an JavaScript object that you can use for your other purposes, you need to json.parse to parse it into a JavaScript object. So data is a JavaScript object that you can use for your other purposes. Right. So let's try to run it. Yeah. Okay. So this is called JSON 8. So you can see that after you pass this JSON string using json.parse, it's passed back into a JavaScript object. Yeah. So this is how we can read and write with JSON file. So this is used for later, in the later weeks, when you want to store your user data or other data in a file without building a complicated database. You can just save the data as a JSON string in a JSON file. So this is what we call file-based database. File-based database. Yeah, we'll explain more about this in a later week. Another type of file is called YAMA. So YAMA is another popular modern interchange format. This is how it looks like. So it doesn't look like JavaScript object anymore, but it also has clear structure. So the name of this group of data is called location. And this is like the first, so similar, this is like the first object and for location, and this is the second object, and this is the third object. But it is not called object in YAML. But the meaning, the semantic meaning is similar. You still have different groups of data. And it has a quite strict format requirement. For example, indentation matters. Like you need to have indentation here, so you cannot start from beginning for postcode. It will treat this subcode as a new object or a new item. So in parallel with location. So the indentation matters. And also a dash is used at beginning of a list item. So similarly, like a list item is like an object, and an object, right? And a very common for configuration. So we will use Yama later as well, but it's quite easy and straightforward. It's also a data structure, right? Similar to JSON, but just different format. XML is very old school one. So there's still some like for financial, fintech, financial softwares, they still use XMLs. But for our project and many other modern apps, like we are not using XML. So you can see that it's much more complicated, right? A lot of redundancy and easy to, hard to read, hard to write. Yeah. It has a few issues, but it's still used in some cases. Okay, perfect. So this is a very short lecture. So this one is only to introduce to you what is JSON file. So we have been using package.json file, but we haven't introduced it yet. So here we are introducing to you what is this JSON file. So all you need to know is it's not an executable file. It's not script like we can run, like we can call like JavaScript file. It's just a type of file that you can save data into it. And it's used for when we want to read and write from a file. Like when you want to save your data somewhere, you can save this. You can save your data in a JSON file, and later on you can read it from the file. Yep. And Yama will see it in a later week, and we will explain more about that. All good? Question? No? Okay. Thank you. Bye.
Is it like a database?
Sorry.
Is JSON like a database?
Yeah, can be used for database. Can be used as a file-based database.
What is different between